Hello guys, today we start to study chapter 4, Energy and the Future. This chapter contains 15 sections divided into 4 parts. In the early edition of this textbook, this chapter was just a section of chapter 3. We will learn about energy problem, fossil fuels, alternative sources, and strategies for future. The first section is about population and prosperity. Population, defined as the sum of all people in the world. Rapidly increases with a rate of 215,000 per day at the present. This fast growth of population drives the world energy demand. The table lists the population of 4 different times or years, and the figure plots the population as a function of the year. The part of the dotted line refers to the prediction for future. The present population is about 6.7 billion people in the world. Prosperity also drives the world energy demand. For better lives, energies used per person per day increase. Therefore, the total energy consumption rapidly increases. Higher today, higher tomorrow. For instance, in 1980, the world energy consumption is about 300 EJ, but in the year 2000, it increases to 500 EJ. Here the unit EJ is defined as 10 to 18 joule. Energy consumption per person depends on where or which country you live. In USA, each person consumes energy at a rate of 9.3 kilowatt. The world average is 4.5 kilowatt. And most people in the world consume energy at a rate lower than 1 kilowatt. Sources of energy can be divided into 2 categories, fossil fuels and non-fossil fuels. Fossil fuels include coal, oil, and natural gas. Non-fossil fuels include nuclear energy and other renewable and clean energy, such as hydrostatic, wind, solar, etc. Currently, about 85% of world energy is produced from fossil fuels, in which coal takes 23%, oil takes 38%, and natural gas takes 24%. These percentages are yearly change. About 15% of world energy is produced from non-fossil fuels, in which nuclear energy takes 6% and other renewable and clean energy takes 9%. As more and more energies are used daily, the climate changes. The average temperature of Earth's surface and atmosphere has been found to be above its history. The average temperature now is 0.5 degrees Celsius, higher than the average temperature during the 30 years from 1960 to 1990. This global temperature increase or global warming causes sea level rise 3.4 millimeter per year, twice as fast as a decade ago, still accelerating due to melting the vast glaciers of Greenland and Antarctica. From prediction by next century, the temperature will increase by 4 to 6 degrees in Celsius and the sea level will rise about 2 meters. We don't want to see that will really happen. The Earth is like a fireball and the polar bears without a homeland. Why the global warming occurs, or why the temperature increase? The reason is the greenhouse effect. It refers to that the thermal radiation from the Earth is absorbed by atmospheric greenhouse gases and then radiated in all directions, especially back to the Earth. This leads to unbalance between the radiation from the sun into the Earth and the radiation by the Earth out to the space. What are the greenhouse gases? Carbon dioxide, CO2, is the major greenhouse gas. Increase of carbon dioxide in atmosphere causes the greenhouse effect and that causes global warming. That produces global warming. Who emits carbon dioxide? Everybody. This table lists the amount of carbon dioxide emitted per person per year in different countries. In USA, each person each year emits about 16 metric tons, and the world average is about 4 to 5 metric tons. Here, 1 metric ton equals 100 kilograms. There are other greenhouse gases such as CFCs, HCFCs, methane, CH4, also called natural gas, and nitrous oxide, N2O. CFCs and HCFCs, usually produced by refrigerators and air conditioners, contribute 12% to the greenhouse gases. Natural gas contributes 20%, and nitrous oxide contributes 6%. The major greenhouse gas, carbon dioxide, contributes 62%. Records indicate that carbon dioxide concentration in atmosphere increases yearly. In 1910, the concentration was only 300 parts per million, but in 2010, it became 390 parts per million, increased by 30%. Where these greenhouse gases come from? The origin of greenhouse gases is due to various activities of human beings, such as 20% from electricity and heat generation, 18% from deforestation, 14% from industry, 13% from transportation, 13% from agriculture, 4% by waste, and 13% from all others. all these activities are related to energy consumptions. As pointed out above, 85% of energies that we consumed are from fossil fuels: coal, oil, and natural gas. Crude oil or petroleum is a typical liquid type of fossil fuel. Transport fuels make up 70% of oil products, such as gasoline, diesel fuel. Burning or combusting with oxygen 1 gallon gasoline produces 8 kg carbon dioxide. From the chemical reaction, we see when two gasoline molecules combine with 25 oxygen gas molecules, 16 carbon dioxide molecules are produced. Natural gas is usually called methane, CH4. Burning natural gas also produces carbon dioxide. Coal contains lots of carbon, and burning coal not only produces more carbon dioxide but also causes pollution. Since coal also contains sulfur, burning coal also produces sulfuric oxide, SO2. Which, when it combines with water, produces acid and leads to acid rain that pollute the air and the ground, including soil. Crops cannot grow in acid-polluted soils. This diagram shows how this happens. Until 2010, 435 nuclear reactors in 30 countries generated about 368 gigawatts of electric power from nuclear energy. France generates electricity 77% from nuclear energy, and the USA is in 21%. Usage of nuclear energy takes risks because reactor disasters may occur. 3 significant reactor disasters occurred historically are the 3 Mile Island reactor disaster occurred in March 1979 in the USA. Due to a valve mistakenly closed, the cooling system was damaged. The reactor was partially exploded and the radioactive materials were escaped. The second was the Chernobyl reactor disaster occurred in April 1986 in Soviet Union. The reactor was accidentally exploded and released large quantities of radioactive particles into the atmosphere. The third was the Fukushima reactor disaster occurred in March 2011 in Japan due to an earthquake and its induced tsunami that damaged the nuclear plant and released large quantities of radioactive particles into atmosphere, ground